1,720 feet. That's the height a wave reached inside a narrow Alaskan fjord on a single summer night in 1958. Not 17 feet. Not 170 feet. 1,720 feet above sea level. That's taller than the Empire State Building stacked on top of itself 3 times over. And the thing that created it wasn't a volcanic eruption or a submarine earthquake out in the open ocean. It was a rockslide. A chunk of mountain simply let go, hit the water, and produced the tallest wave ever recorded in human history. Here's what's genuinely unsettling about that. The second tallest wave ever recorded happened last year. Same state, same mechanism, and almost nobody noticed it happening. So let's actually run through how something like this is even physically possible. Lituya Bay sits on Alaska's panhandle, carved into the coast along the Fairweather Fault. It's a T-shaped fjord, roughly 7 miles long and only 2 miles wide at its broadest point. The entrance to the bay narrows down to a throat just 33 feet deep at the sill. That geometry matters enormously. It's essentially a bathtub with extremely steep, extremely tall walls and almost no exit for water to escape through. When something massive hits the water inside a space like that, the wave has nowhere to go except straight up. On the night of July 9, 1958, that's exactly what happened. A magnitude 7.8 earthquake ripped along the Fairweather Fault that evening. The shaking destabilized a massive section of mountainside above Gilbert Inlet, the northeastern arm of the bay. Roughly 40 million cubic yards of rock broke loose from an altitude of about 3,000 feet and plunged directly into the water below. To put that volume in perspective, that's enough material to fill roughly 15,000 Olympic swimming pools dropping all at once. The impact displaced water with a force that engineers and geologists still describe as almost incomprehensible. The resulting wave climbed 1,720 feet up the opposite slope, stripping every tree, every layer of soil, everything down to bare rock at elevations higher than most mountain summits in the eastern United States. The trim line it left behind is still visible in satellite imagery today. Here's the part that genuinely reframes how you think about this. 5 people died. 5. On a night when a wave that tall hit land, the death toll fits in a single sentence. The bay was remote, lightly populated, and the few people present were on anchored fishing boats. 2 of those boats were actually lifted by the wave and carried over the spit at the bay's entrance. 1 boat survived, 1 didn't. The survivors described watching the tree line on the opposite mountainside get erased from the top down as the wave climbed. That's the kind of account that tends to stay with you. What kept the casualty count low wasn't good planning or early warning systems. It was luck, pure geographical isolation and the specific hour it happened. Now, the reason the 1958 event matters beyond the record books is what it forced scientists to actually reckon with. Before Lituya Bay, the working assumption was that waves that large were essentially mythological. Ocean-wide earthquakes could generate serious tsunamis, sure. But a localized wave climbing 1,720 feet, that wasn't in the engineering models. That wasn't in the hazard assessments. The 1958 event forced a genuine reevaluation of what landslides hitting confined bodies of water could actually produce. It's where the term megatsunami was formally established to distinguish these extreme localized events from conventional earthquake-generated tsunamis that travel across open ocean. 2 completely different animals, even though people tend to lump them together under the same word. The mechanics behind why landslide tsunamis get so extreme in fjords come down to geometry and energy transfer. When a landslide enters open ocean, the energy spreads outward in every direction simultaneously. The wave loses height fast. But in a narrow fjord, that outward spread is physically blocked by the walls. The energy has to go somewhere, so it climbs. The steeper and narrower the fjord, the more dramatically the water is forced upward rather than outward. It's not a subtle difference either. The same landslide volume dropped into open coastal water versus dropped into a confined fjord produces waves of completely different scales. What would be a serious but survivable event in one setting becomes a terrain-altering megatsunami in the other. Lituya Bay is essentially a worst-case geometry for exactly this reason. Which brings us to August 10, 2025. In the early morning hours, before most people were awake, A landslide roughly the size of 12 city blocks tore loose from the northern wall of Tracy Arm Fjord, about 50 miles southeast of Juneau. It slammed into the South Sawyer Glacier and sent debris cascading into the water below. The landslide volume was actually larger than Lituya Bay, around 64 million cubic meters of material entering the water. The initial wave reached 328 feet. The runup, meaning how high water climbed up the surrounding slopes, hit figures that placed this event as the second highest tsunami run-up ever recorded. The record from 1958 held, but just barely in historical terms. And here's the part that should genuinely bother you. It went completely undetected in real time. No alert, no warning, no official notification that a wave of that scale had just reshaped a stretch of Alaskan coastline overnight. The reason that detection failure matters isn't academic. Tracy Arm is a popular destination for cruise ships and small tour boats. Thousands of tourists visit that fjord every summer, specifically to see the glaciers up close. The landslide happened at 5:30 in the morning on a Sunday, in early August. Had it happened 4 hours later on any given summer weekday, the geography and the timing line up badly. Researchers who published the study mapping this event were direct about it. The landslide was a hazard. It went undetected, and that is a problem. Glacier retreat driven by warming temperatures is actively destabilizing the slopes above these fjords. The ice that once buttressed those valley walls is thinning and pulling back, leaving steep unsupported rock exposed above cold deep water. Lituya Bay produced its record in 1958 and forced a scientific reckoning. Tracy Arm just quietly posted the second entry on that same list, and most of the world found out about it from a journal article published months later.